Okay, so for question 8a, okay, what they ask us to find, they say approximate by using the trapezoidal rule n equals to 4, and then give your answer. Give your answer correct to 4 decimal place. So we have to find out this integration using trapezoidal rules first. So obviously n is equals to 4, we just need to find out what is our h. So h will be b minus a over n. So what is your upper limit? B is upper limit, 1 lower limit is 0 over 4. So 1 over 4 here. Then we continue. We're building up our table. So when you have n over 4 means our ordinates, okay, the point ordinates x will be having 5 x1, x1 until x5. Okay, so we draw out our table. 5 ordinates, 5 row plus total plus, so it will be 7. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6. Oh, heaven, 7. X column, Y column. So write it down, X column, Y function going to calculate X square root of 1 minus X squared. Starting X1, X2, X3, X4, X5, lastly is total. So starting from 0 up to 1. So Y1 here, Y2, Y3, Y4, Y5. Okay, calculator. Take the mode of table. Function alpha x times with the square root of 1 minus alpha x squared equal gx. Don't have, skip. Beginning, start with 0. Our upper limit 1. Step is 1 over 4. Okay, so come out already 0, 0 0.25, 0 0.5, 0 0.75, 1. So y coordinate, how many decimal there? 1. There 1, how many decimal? 4. So here we're taking 6. 2, 4, 2, 0, 6, 1. Okay, so 4 no need to round off. Oh, this is y2, yeah. Y1 is 0. Y1 0, Y2, Y3. Next. Okay, so done. Clear it off. Okay, trapezoidal rule, approximation method. Approximate to h over 2, and then 0 plus 2 times this. So 4 decimal place, 7 become 8. Seven marks. Okay, so this mark I don't have, so we just finish it only. Okay, so for this, they say use substitution in topic 1. We have to show this integration getting 1 over 3. So concept of substitution, when u is equal to 1 minus x squared, then we see the question part. So this part already become u. Okay, so for x dx 7, so we have to substitute all this x dx and the value of 0, value of 1. So to substitute dx, we have to differentiate u with respect to x. So differentiate 1, cosine 0. Differentiate this x, power, move to the front, power minus 1. So what we have is multiply it x dx. Yes, we can see x. Okay, so we can see exactly the things is at here. This is our x, this is our dx. So this is our x dx. So means that our x dx can be substituted by negative 1 over 2 du. Okay, move this negative 2 to the left hand side, become negative 1 over 2 coefficient. Coefficient for this du. So done. Now is our value of x. When x is 0, we have to find out our u is 1. When x is 1, our u will be 1 minus 1 squared, which is 0. Substitute our assumption here. Substitute our u equation here, so that to change everything in terms of u. So after that, then we can start integrate. So integrate 0 to 1, x, square root of 1 minus x squared dx. Okay, we substitute from the 0 for the x 0. When you substitute here, the value of u is 1. So our new terms here become u. This is 1. For x is 1, our u term is 0. For x dx, it is multiplied with 1 over 2 du for this square root u. Okay, so inside here is square root u. So now we're going to integrate this. So to integrate this, simplify first. So constant can be simplified out. Then u, we have to rewrite it to the power so that we can integrate it. Power plus 1. So it will become 3 over 2. Then divide by new power 3 over 2. Okay? Because you said divide by 3 over 2. So same meaning with times with 2 over 3. So normally I will put 3 and then 2 automatic up, go up to the numerator part. Then when we have limit, so our next step is substitute limit. And find out our answer. So of course we can press this. Okay, we can press this calculator. See it can calculate for us or not. So inside here is square root u. I don't have u, I just put x only. So 1 to 0, up there, negative half. Yeah, never mind. Okay, then time is negative half. So this is 1 over 3, right? So supposedly this is 1 over 3 lah. Okay. Or I can accept decimal. Okay, alright, I will accept decimal because this topic is talking about decimal. 0.33. How many decimal that we need? It will be depends on part A because we want to compare the result from part A. So 4 decimal. So after finish this, then we come back to the question. They say, give the reason, the difference that obtained in part A and part B. So from part A and part B, there are difference. So we look at the differences here. Okay, so we have some differences here. So they say, it's not finding the differences. They say, give the reason why we have these differences at here or occur at here. Why it will happen? Because we have to explain. We have to explain. Just now, what we do is trapezoidal rule. So this is not exactly value. This is approximation value only. So, but this one is directly integration. So directly integration, of course, this will be the exact value. So this both method they have difference. Most probably because of the concept of the method. So this method is approximation method. So that's why we will obtaining a difference here. Okay, so the reason there has a difference between the two answer because trapezoidal rule is an approximation method only using four stripes. Four stripes of trapezium. Another method here is direct integration, which give an exact value. Okay, so kita punya alasan ialah sebab ini trapezoidal rule adalah approximation method. Hanya guna four stripe. Sekiranya kita kita nak kurangkan dia punya perbezaan. Okay, dia punya tanya boleh tanya macam tu. Sekiranya kita nak kurangkan dia punya perbezaan daripada exact value here, what can we do? So, okay, so you can take notes here. This is extra information you can learn. Okay, extra information. So to reduce the error or difference. Okay, so we can suggest our trapezoidal rule. We can use more stripe of trapezium so that means you're going to increase the n value, so that our approximation value will be closer. Okay, to increase the n, to increase the accuracy. Okay, to reduce the error or difference, we can use more stripe of trapezium to increase the n, so that to increase the accuracy from our trapezoidal rule. So the concept is like this. So you can look at our diagram here. You just imagine this is four stripe. You can see some part of the place we not calculate. So that's why we have error. But if we increase the stripe of the trapezium here, so of course we can cover this better. We can cover the graph by our trapezium better. So the place of empty space, maybe we can cover it up. So our error will become smaller. So our answer will be more accuracy. But of course lah, our table will become longer. That will bring us to more accuracy result.